So for this first question, we know that it's asking us to calculate the present value of a bond. And since bonds pay coupons out twice a year, we need to change our PY to 2 before we start this problem. So to do that, you hit second PY, and right now my calculator has it set for 1. So we want to go ahead and hit 2 and then enter. And then we can get out of that by second quit. And we want to make sure that our TVM keys are cleared out. So you just want to hit second clear. And that sets us up for 0 in all these values. So this first one is N, and that's the number of payments paid out. IY is the interest rate or yield rate. PV is the present value of some investment or bond. Payment is either what we're paying in or receiving out from a bond or from an investment. And future value is the future value of either an investment or the par value of a bond. So in this first problem, we know that we have a par bond of 1,000, so we can go ahead and put in the 1,000 for the future value. And in this problem, we're told that we have 6% semi-annual coupons, so that means that we get $60 per year. So we actually get $30 per semi-annual, so that's what we want to put in the payment. And then we know that we have a yield rate of 10%, so we can go ahead and put that in IY. And our N value is going to be twice the years of the bond. So it's a 10-year bond, so we put 20 in since we pay coupons semi-annually, so twice a year. And then we can go ahead and hit compute PV, and that gives us our present value of our bond. So this second question is not looking at a bond, it's looking at some initial investment. So what we want to do first is go back into PY and make it 1. Since this is an annual effective interest rate, it's not semi-annual. So we want to go ahead and put a 1 in there and hit enter. And then we can get out of that. And we know that we're looking at a future value of $1 million, and we're looking at that in 40 years. And we also know that the interest rate on the account is 10%. So we have everything that we need to go ahead and be able to calculate some initial investment that we would need to put into an account so that in 40 years we have $1 million. So first we'll put 40 in for N, and we know IY is 10. And we also know the future value of our investment is 1 million. So then from there, all we need to do is hit compute PV, and that gives us our initial investment that we would need to put into an account. We need to put about $22,094.94. Okay, so for this problem, we're asked to calculate something a little bit different. We're actually asked to calculate the future value given that we're investing some amount equal each year for 10 years. So we're told that we invest $2,000 every year for 10 years at a rate of 5%, and it's asking how much money we will have in 10 years. So for this problem, we're actually not going to use the present value. That assumes that we've invested just one lump sum, and from there we're looking at the future value. But for this problem, we actually have invested $2,000 every year for 10 years. So we need to look at the payment because we've paid out $2,000 for 10 years. So we can go ahead and put in 10 for N. And we know we receive an interest rate of 5%, so that's IY. And we're going to place the 2,000 under payment. And then we can go ahead and hit compute, future value. And this tells us that in 10 years, our $2,000 investment per year will give us a total sum of about $25,156. Okay, so in this problem, we're asked to compare two separate accounts that we have the option of investing $1,000 in. We know account A compounds interest on a semi-annual basis of 4% effective, And we know that account B compounds interest annually at an effective rate of 8%. And we want to look at the future value of our $1,000 in each account to be able to compare the two and see which one would be a better option for our investment. So we'll go ahead and start with account A. And we know that account A compounds interest on a semi-annual basis of 4%. So we actually want to put 2 in for IY. Since we know this is semi-annually, you need to divide your interest rate by 2. And then we're looking at this for 12 years in the future. So we actually want to put 24 in for N. Since our interest rate compounds semi-annually, we actually have 24 times that our interest compounds. And then we also know that the present value of our investment is 1,000. So we go ahead and put that in PV. And then we want to hit compute future value. And you can see that this account earns an amount of about $1,608. So go ahead and keep that value in mind, and we're going to go ahead and calculate the future value if we were to put our money into account B. So hit clear, second to clear our TVM values. And in this instance, we have an annual effective interest rate, so we can go ahead and put the whole 8% in IY. And we can also keep N at 12 since it's an annual interest rate. And then the 1,000 will be in present value again. We can go ahead and hit compute FV. And you can see that this account earns us about $2,518. And so in this instance, you would want to choose account B for your $1,000 investment because in 12 years you will have more money in the account than you would in account A. Okay, so for this question, we're told that we have just won $5,000 and we're interested to know how long it would take for us to double our money if we were to put that $5,000 into a savings account today that earns 12% annual effective interest. So in order to do this, this N is our unknown in this particular question. So we can go ahead and put in negative 5,000 for PV. And then we want to double it, so we want $10,000 in the future. And we know that our interest rate is 12%, which we can put in IY. And then you can get compute N, and we now know that in 6.11 years, we'll have $10,000 in that account. So for this question, we're told that we're investing $3,800 into an account today, and we're interested to know how long it will take for us to accumulate $20,000 in that account. In this question, we are given a quarterly effective interest rate rather than an annual interest rate, so we'll have to do a minor extra calculation to be able to do this problem correctly. So we know that our effective rate of interest that's quarterly is 8%. So since it's quarterly, we actually want the percentage for every quarter. So you'll do 8 divided by 4, which is obviously 2. So we're going to store that in IY. And then we know that we've invested $3,800 today. So that goes in the present value. And we want $20,000 in the future. And then we can go ahead and hit compute N. And this says that we need 84 periods to be able to accumulate the $20,000. So that actually means that we will have accumulated this in 21 years. Okay, so for this next problem, we're actually asked to calculate the interest rate we would need an account to have in order to be able to save up for some future value investment. So in this instance, we're buying a car 7 years from now, and we've estimated that we need around $25,000 to buy our car. And we currently have $10,000 that we can place into an account. And we're interested in knowing what type of interest rate we would need to be able to accumulate the $25,000 in 7 years. So the first place we want to start is that we know we're looking 7 years in the future. So we can go ahead and place 7 in N. And our present value is $10,000. We currently have $10,000 to put into the account. And we want to make this value negative since it's an outflow of money. And if both our PV and FV were set at positive values, you'd actually get an error for IY. It's up to you which one you want to set negative, but just remember that PV or FV, either one of them needs to be negative. I'm just going to go ahead and make PV negative. And we want $25,000 in 7 years. So we can go ahead and compute IY. And we see that we would need an interest rate of about 14% in that account to be able to have $25,000 in 7 years. Okay, so for this one, we're given information about a bond, and we are not paid out any interest or coupon payments throughout the life of the bond. So it's asking us what rate of return we would earn on the bond if in 14 years we receive $4,000 for a bond that we purchased for $500. So we know that our N value is 14 years of the bond. And we know that in 14 years we've earned $4,000, so that's our future value. And when we initially purchased the bond, we purchased it at $500. So it's negative 500 placed into PV. And to find the rate of return, that's actually our IY value. So we can go ahead and hit compute IY. And for this specific bond, we have earned a rate of return of about 16%. Okay, so in this problem, we're looking at saving money for college, and you want to save $100,000 for your child within 10 years, and you're interested in placing money into an account every 6 months to meet this $100,000 goal. We currently know that the account earns an effective interest rate of 10%, and that's an annual percentage, and it's asking what amount we would need to put into that account every 6 months to accumulate to $100,000. So to start, since we know that we're looking at this for every 6 months, we're going to take our annual effective interest rate and split it in half. So if it's 10%, we want to put 5 in for IY. And we're looking at this 10 years in the future, but we're paying into the account every 6 months, so we're actually making 20 payments, so that's our N value. And we know that we want to have $100,000 in that 10 years. So for this problem, we actually don't need to use PV again. We're just going to be looking at payments. So you can go ahead and hit compute payment. And we know that we would need to put $3,000 and around $24 into our account every 6 months for 10 years to have $100,000 for our child to go to college. Okay, so for this problem, we're given that we have a mortgage loan of $120,000, and the interest rate on that loan is 8.3%. And we plan to make 360 payments, and we're asked to calculate what our monthly mortgage payment would need to be for this loan. And so when it gives you 360 payments, what that actually means is that this loan is it's a 30-year mortgage loan. So that's actually going to be our N value. And then we know that our annual effective interest rate is 8.3%, so we can go ahead and put that in IY. And we know that our future value of our mortgage is $120,000. And we want to look at our payment. So we can go ahead and compute payment. And to pay off that $120,000 loan in 30 years, we would need to pay $1,002 every month. Okay, so for this next set of problems, we're going to be dealing with annuity immediates and annuity dues. There's a certain setting in the calculator that can make this a lot easier, since annuity immediates have payments at the end of the year and annuity dues have payments at the beginning of the year. It's going to affect the present value and future value of the problem. So the first one we have is an annuity immediate, which means that the payments are at the end of the year. So your calculator will be set for this, but I'll go ahead and show you. So you click second payment because it has the BGN, which means beginning. And right now we have it set for end, which is what we want. So we can go ahead and hit second quit. And then we know that we're making payments of $1,000. So that goes in payment, 4% for IY, and we're doing that for 10 years. And it asks us to compute the present value and the future value. So you can do compute PV. You'll see that our present value of that investment is about $8,110. And then we'll do the same for the future value. We have 10 years, 4%, $1,000 payments, compute FV. And our future value is $12,006. So in this next problem, we're given the same values for the payment, investment percentage, and the years. But in this instance, we have an annuity due. So that means that our payments are made at the beginning of the year. So to change that, you go second payment, second set, and now you have set it for BGN, which means the beginning of the year. And you can go ahead and hit second quit. And you know that your calculator is set for that because it brings it up in the corner here. So then we can go ahead and do what we normally do. Just input all the information, and we'll compute the present value again first. And in this instance, now that we're making payments at the beginning of the year, our present value is $8,435. We'll go ahead and do the same thing for the future value. 10 years, 4%, $1,000 payments. And compute FV, and we now have $12,486 for our future value. Okay, so for this next one, we're given a series of cash flows for 6 different periods, and we're asked to calculate the net present value and the internal rate of return. And we also know that the discount rate is 10%. So to do this, we actually won't be using the keys we've been using in the past. We'll be using these 3 up here, CF, NPV, and IRR. So to start, you're going to input your cash flows. And in our instance, CF0 is the initial cash flow. So in our case, it's negative 2,000. You hit enter. And then cash flow 1, which is 1,100. And then you'll see F01 come up. That's the frequency, which means how often was this payment made. So in some instances you may have a cash flow of 1,000 done 3 times in a row, in which case you would change the frequency to 3. But in our case, the 1,100 was only inputted once. So we're going to keep that at 1. And then cash flow number 2 is 1,500. Again, frequency of 1. And then we have 1,800 for 3. And 4 is 2,100. And 5 is 2,400. So now that we have all that in there, we need to go into the net present value. And the I is where you'll put the discount rate. In my case, I already have the 10 in there. So I'm just going to scroll down and hit compute. And it brings up that our net present value for these cash flows is $4,517. And then to go on, our internal rate of return is 68.308589%. And to do that, all you do is scroll over to this and hit compute. And it'll come up right there. So another useful part about this calculator is that it actually has the store and recall keys inputted into them, which is very helpful since this isn't a multi-line calculator like some of the other ones you might have been able to use in other classes. In this case, you only will see your most recent computation, and in cases like the actuary exam or exams that you're time crunched on, you're not going to want to have to write down every previous calculation you've made that you need for moving on within the problem. So the store and recall keys will come in very handy in many different instances, and I'm just going to show you a quick example of how this could help. So say I needed to do 75 divided by 4, and that gives you 18.75. I'm going to go ahead and store that in key number 1, and then I can move on and say, well, I needed to do 15 divided by 2 times that number. So you'd go times recall 1, and it'll bring up that initial calculation I made, and you'll hit equal, and that'll give you your final answer without you having to take the time to write down the 18.75 in order to remember it for the future calculations. So for the actuary exams, there's a very important step that you need to remember going into them, since they are a proctored exam and they want to make sure that there's no cheating going on or anything like that. So when you go into the exam, whichever one it is that you're taking, they're going to reset your calculator, and in some instances this may take away those settings that are very important for the calculations you're doing. So I just wanted to show you real quick what you need to make sure that your calculator is set at in order for you to be able to make sure that you're making the right calculations. So the first place we're going to go is second and down here to format. And they recommend that you either have it set anywhere between having decimals to the fourth decimal or all the way up to the 6th. I like to go to the 6th just so that I know I'm not making any errors in the calculations solely based on the fact that my answers were rounded. And then the next place you want to go is to make sure that your date and time are set to US. And you want to make sure that you're doing calculations using the chain rule. And that's the last part in this certain formatting area. And the other area is one that I touched upon when we were calculating bonds, but you want to go here and look at your PY and just make sure that it's set to 1 in both cases. And then if you happen upon an instance where you have semi-annual coupon payments, like with a bond, then go ahead and set your PY to 2, but just keep it at 1 to be safe for all your other calculations. And besides that, that's pretty much it. Just get really comfortable with your calculator since it is a time-sensitive exam. You want to make sure that you're not having issues using your calculator rather than just focusing on the actual problems.